I think another challenging part about your unit test having electron arrow pushing on it is that we're not going to see it for a while. So we kind of covered the bases and we looked at ways that it applies to the chemistry, but we're going to come back to it after the midterm and we're going to apply it to reactions. It's not something that's gone yet. It will show up on the midterm. So it's still something I want you to be able to interpret. I want you to review it, but we're gonna have to predict how the electrons move in the second half of the semester.
I got that problem, and I put the carbon there, but I just put it C next to O.
Oh.
Instead of the like corner, I just put the C and O together.
Maybe I missed the C.
I mean, it's on my picture.
Did I take off points for the same thing and leave
I have
those?
no idea. I haven't looked at my schedule.
Oh, I maybe haven't graded yours yet.
Okay.
If you
It was yesterday afternoon.
if you submitted after 6 p.m., I didn't get to grading it yet. And I think that's what it was. I don't think I've graded yours yet.
Would that be wrong? Because it doesn't have the angle, it's just the C and the O together.
Yeah, so if you have this line and then
Yeah.
C,
Yeah.
it's a bit awkward. And the reason it's awkward is because you're not showing the two hydrogens that are there as well.
Okay. So you would want to show all the letters representing if you're doing like a
Yeah. So there's that like
the OH at one end or
there's that awkward thing of in bond line we can assume all of the hydrogens. We don't have to explicitly show them. Well, we can also assume all of the carbons. But then as soon as you start explicitly showing the carbons, you should probably explicitly show the hydrogens too, because otherwise it feels kind of clunky to show a carbon but not its hydrogens. So I'll keep that in mind. I'll think about it. It would be a lot. If I take points off for it, it would not be as many points as I took off for totally losing the carbon, because you didn't lose the carbon. Speaking of which, that was a 3-point problem. It was 1 point for addressing the acid and base. It was also another half. Well, the other 2 points were split between showing the correct products and conserving charge correctly. So with showing the products, it was do the right bonds form and do the right bonds break. So that's kind of like half a point each. And then the other was, is charge conserved? In this case, I have a net neutral reactant side, and I should have a net neutral product side. And then also, is charge conserved and appropriate charges shown? So if you had given me this product, but then also put a positive and a negative, you could have gotten half a point because it's still net neutral, but you definitely would have lost a point, half a point, because those are not appropriate charges. So when it came to the 1 point for showing the products, I think that I took a quarter of a point off for losing a carbon atom. You showed the correct bonds forming and or the correct bonds breaking, but you lost an atom along the way. So that was a small part of the total point. And for a lot of people, that was the only part that they lost. And I recognize that on a 5-point test, a quarter of a point is 5%. So you lost that one carbon, you got brought down to a 95. And if I had taken a half a point, it would have been a 90. And I just didn't feel like that accurately represented how well you interpreted the problem. I felt like a 95 represented better how you did on that problem, on the test as a whole, really. All right, other comments or questions or concerns from the unit test? You guys have got 4 more of these, so I want to make sure that you feel confident.
Are we doing confirmations after SHAs?
In this next unit, we're looking at confirmations, yeah. Good segue. We're now in Unit 2. And Unit 2 is going to cover 3 different sections. I am trying to get better at learning objectives. So, presenting to you guys why we're doing what we're doing in class. By the end of today's lecture, I want you guys to feel confident in your ability to identify functional groups. So that's what we're going to spend a majority of our time on today, is looking at functional groups. And then tomorrow we'll move into nomenclature and conformations. So we're going to look at things called regiochemistry and stereochemistry. Now, before I give a definition, I would love to hear from you guys. Do you have an idea already, a picture of what functional group means? Do you have a working definition in your head? Russ?
The same idea as an R group on an amino acid.
Nice. Okay. So I like the connection to amino acids because I know a lot of you guys are doing something with medicine, might even be biology majors, so you're going to learn the amino acids. And then there's this R group, the side chain, I think they call it. So let's just give an abbreviation here. An amino acid has this base template. We actually looked at this amino acid the first time we drew bond line structure. This was glutamate, glycine. And then off of this carbon here, there's this R group, and sometimes even off of the nitrogen. This doesn't always have to be NH2, but this is sometimes NHR. I think there's one where these two R groups actually link together, and you've got a cyclic structure with the nitrogen. So a similar idea. What is coming off of here might be a functional group. It's going to differ in what atoms are there and how they're bonded. Let's see if we can work down a definition a little bit more. Any other ideas? Did you guys do the reading? Did you get a preview of what this means? And do you have a blurry idea of what the definition is? Maddie?
It's like a little chunk on a molecule that gives it certain properties and behaviors.
That's good. It's a little chunk on a molecule where you can predict certain properties, certain behaviors, whether that's polarity or reactivity. And it doesn't matter what the rest of the molecule looks like. You're just zooming in on this little chunk and looking at what it does. Let's see if we can improve our wording for chunk. What does chunk mean?
I feel like it's like a molecule within like a structure.
Interesting. It's a molecule within a structure. I'm going to have to push back on that definition because I think structure and molecule, they go hand in hand. But I think I get what you're trying to say. It feels actually very similar to the chunk. I'm just looking at this little chunk. I'm looking at this particular part of a molecule. Let's do Aaron first.
A specific atom combination and structure.
Okay, a specific atom combination and structure. Hayden, you want to add anything to that?
Yeah, I'd probably say classification of heteroatoms allows to determine the properties of behavior.
Now, Hayden, you brought heteroatom into it, but heteroatoms don't need to be in there in order to be a functional group. There is a very large class of functional groups that have heteroatoms, but those are just specific types of atoms. So I'm actually going to take Aaron's definition and we're going to kind of workshop it. Now, you said
Specific combination of atoms in a specific structure.
specific combination of atoms with specific structure. I'm going to change structure to bonding. So a functional group is a specific set of atoms with specific bonding character, or in other words, these are just specific bond types or groups. A functional group contains at least 2 carbons, but also upwards of 6 or more. I think I said carbons, sorry. A functional group consists of at least 2 atoms, but upwards of 6 or more atoms as well. And the type of bond that they have. You cannot classify a functional group easily without naming the types of atoms and the way in which they're bonded. And then, because you have created a set of atoms and bonds, those can make up just a small portion of a molecule, and the rest of the molecule can have lots of other functional groups. But every time you see that set of atoms with that bonding type, you know it's going to have characteristic properties. You know it's always going to react in the same way, it's always going to give the same product. It might even have the same physical properties as well. But often we look at their characteristic chemical reactivity. And that's what I'm going to add here, with characteristic chemical reactivity. That's really wordy. But it's hard not to make it wordy. If you can take that definition and slim it down, I'd love to take it. The idea too, I'm not a big fan of having a rigorous definition for everything. I think that there are often many ways that you can try to define something. So you can ask AI, how do you define functional group? You can look it up in a dictionary, and there's probably going to be different ways of approaching it, different ways of thinking about it. All right, 3 classes of functional groups that I want us to really work with. And I'm going to give us an activity to explore these, but first I want to lay these out. Let's start with our hydrocarbon groups. You'll notice something about most of these groups. They start with ALK. I don't know what that means, but it's characteristic, and we're going to see that ALK feature a lot this semester. Alkane, alkene, alkyne, aromatic rings, aka arenes. The alkane functional group is not considered a functional group by some people. It's the base of all hydrocarbon functionality. This consists of carbon-carbon single bonds and hydrogens, which means that we're really only dealing with sp3 hybridized carbons. That's the rigorous definition of alkane. It only has carbon-carbon single bonds in addition to the hydrogens. Alkenes involve sp2 hybridized carbons, but not just any of the bonds that sp2 hybridized carbons can make. sp2 hybridized carbon-carbon double bonds. Anytime there is a carbon-carbon double bond, that bonding type is called an alkene. Do you know a lot of people get tripped up on how to say this? So I want you guys to say it with me. Alkane,
Alkane.
alkene,
Alkene.
alkyne.
Alkyne.
You hear that I in the alkyne. What's the natural progression? Alkane, alkene, alkyne. sp3, sp2, sp. Single bond, double bond, triple bond. Some of you on your unit test were told to take a chemical formula and draw a molecule with a specific hybridization. How many of you drew an sp2 carbon-carbon double bond? I know at least one of you did. I saw it. None of you drew a carbon-carbon double bond. All right. How about a carbon-carbon triple bond? That's 4 of you. That's great. Now, not all of you that had the sp requirement in your formula went with a carbon-carbon triple bond, because there was also nitrogen in there, and some of you put a carbon-nitrogen triple bond. So that means it's not an alkyne. That's a different functional group, because it's a different bonding type, different atoms in the bond. The aromatic ring, the arenes, these consist of a 6-membered ring with 3 alternating double bonds. We've looked at this one before, and we abbreviated it as pH. That's the C6H5 that sometimes bonds to other stuff. Okay, notice that there are no heteroatoms. So these functional groups consist only of hydrogen and carbon, are hydrocarbon groups. The next class that I want to look at are the carbonyl families. Now, carbonyl is a bonding type. Carbonyl is a CO double bond. And yet, CO double bond is not a functional group. Carbonyl is a class of functional groups. Carbonyl is not its own functional group. First, we have the carboxylic acid, sometimes abbreviated as Ca. Then we have the ester. We have the amide. We have the, there's a lot, and I'm gonna narrow in on a handful of them right now. The acid chloride, the aldehyde, and the ketone. That's just a selection. Actually, the only ones I'm really missing are the acid anhydride and then any that contains sulfur. We're not going to deal with a lot of the sulfur groups this semester. Not that they're any more difficult, they're just less common in the examples that we're going to do. So we know that each of these groups is going to have a CO double bond. What distinguishes them from each other then is what's bonded on the other sides of the carbon. And in order to abbreviate some of this, we're going to introduce R. There's a couple of different ways that you can think of what R means. Most people like to say that R means rest of the molecule. Who cares what it is? It's just everything else. Some people like to say that R is specifically a carbon group. It has to start with a carbon, and then it can be anything. But rigorously, in the field of organic chemistry, R is just used as a placeholder. Substitute it for whatever you want. There's a lot of physical organic chemistry. How does the chemistry of my reaction change? How does the reaction speed up or slow down if I substitute this hydrogen with a halogen or with a carbon group? And so we can put R there to just represent the rest of the molecule. Sometimes it's long, sometimes it's short. For the carboxylic acid, our carbonyl is bonded to an OH group plus an R group. Doesn't really matter what's on the other side, so long as one side is OH. An ester has the carbonyl bonded to an OR group. R here doesn't have to be the same. And sometimes we can distinguish that by making one of the R groups prime, R and R prime. On one side of my carbonyl, I have the rest of my molecule, and then I have oxygen bonded to the rest of the molecule, bonded to something else. There is an important distinction here, which is to say that R prime can't be what group or atom? Can't be a hydrogen. If R prime there is a hydrogen, it's not an ester, it's a carboxylic acid. And what does it matter? Well, we've got specific bond types, specific bonding groups that have different characteristic reactivity. A carboxylic acid has distinct reactivity from an ester. And so if I say that OH counts as an ester, it's not going to behave like all of the other esters. The amide. Carbonyl bonded to a nitrogen group. Now that could be NH2, it could be NHR, kind of like what we were talking about with our amino acids. It could be NR2 prime, it could be two different R groups, could be the same R group. There's a lot of variation that can come in with that amide group. The acid chloride looks like a carboxylic acid, but instead of an OH, it's a Cl. That one's pretty straightforward. The aldehyde, attached on one side of the carbonyl, is just a hydrogen. We term things like carboxylic acids and aldehydes as terminal functional groups. The carbon chain doesn't extend beyond the carboxylic acid. The carbon chain doesn't extend beyond the aldehyde. The carbon chain terminates there. And then a ketone, an R group on both sides. And again, we can designate these do not have to be the same R group. So we can say R and R prime. Okay, this is the most generic form. And I don't necessarily encourage you to memorize these generic forms so much as I encourage you to apply these generic forms to molecules that you see. Because when that R group becomes the rest of a molecule, it can look really different. So you need to be familiar with pulling these bonding groups out of a molecule, distinguishing it from the rest of the structure.
And the ketone groups, like, so would that R prime be anything besides one of the other ones?
Yeah. So, for instance, R prime cannot be H.
Yeah.
R prime cannot be Cl. It can't be a nitrogen group. Can't be an oxygen group.
But anything else?
Yep. Which basically makes it just a carbon chain. As long as it's a carbon chain, it's a ketone.
Okay.
A carbon chain on either side.
You said it doesn't have to be the same, but can it be the same?
Absolutely.
Okay.
You guys know
It
acetone?
doesn't- oh,
Acetone has two CH3 groups on either side of the carbonyl.
and that's
So they can be the same.
everyone with the R prime. It can be the same, but it doesn't have
Right.
to.
Now, to make things even more confusing, here's a molecule that is called formic acid. You guys ever dealt with formic acid? Yeah, good. I don't think you want to. This builds up in your body. It kills you. If you consume methanol, your body metabolizes methanol into formic acid, and then that formic acid kills you. What functional groups are present in formic acid? You're shaking your head like none of the ones we've listed. But you would agree there's a carbonyl, so it's got to be in this family. And I'll give you a hint that there are two functional groups in this one carbon molecule.
Is it the hydroxyl and the ketone?
Well,
Or would it just be a carboxylic?
so no ketone, because there's no carbon on either side of the carbonyl.
Oh, that's really
Carboxylic acid and ester.
Not ester. So it is carboxylic acid
Aldehyde.
and the aldehyde. I've got my carbonyl with OH. That's characteristic of my acid, which is why you hear in the name ic acid, carboxylic acid. And I've got a carbonyl with a hydrogen on one side, which is characteristic of the aldehyde. So this is the confusing part about functional groups. One carbon doesn't have to be just one functional group. That one carbon is two functional groups at once. In fact, the form part of formic acid, it represents a one carbon aldehyde group. So if you've ever heard of formaldehyde, that embalming agent, formaldehyde is a one carbon aldehyde. It's just a dialdehyde. There's a pretty common organic solid called dimethylformamide, which is where the nitrogen is attached to methyl groups, two CH3 groups, and then on the other side of the carbonyl is a hydrogen. So some functional groups can be, or multiple functional groups can sometimes be found on the same atom. But certainly within a molecule, there are many functional groups. Okay, how you feeling? Haven't lost you yet? Just looking at generic bond types and seeing why we put these definitions on it. The last class of functional groups are just our heteroatom groups. It's hard for me to go through all of these. So I'm going to pick some of these that are more important to us this semester. And I'm going to try to keep them similar to this list on the left because there are heteroatom functional groups that resemble a great deal the carbonyl groups, but they are not the same because they have different chemical reactivity and because their bonding pattern is different. The group that's most similar to a carboxylic acid is the alcohol. The alcohol is abbreviated as just ROH. Now, I've given you guys this functional group table. This was one that I crafted a few years ago. And you'll notice that at the top I say R cannot include a carbonyl. So if this carbon that is being represented by R attached to the oxygen is a carbonyl carbon, then it's not an alcohol, it's a carboxylic acid. And there's another distinction I want you to draw here, which is when you see carbon OH, it's not always an alcohol. For instance, this molecule only contains a carboxylic acid. It does not contain a carboxylic acid and an alcohol. You see what I'm saying? I can't look at this bonding and say that it's an alcohol and then expand my bonding region and say it's also a carboxylic acid. No functional groups can, like, gotta be careful how I say that. Take a small part and a bigger part and break it into two different functional groups. There's no overlapping here. The reason I gotta be careful is because we did reuse the carbonyl for two different functional groups here. That's a little bit different. I didn't just take one region and then expand it. I looked at a totally different region.
Is it true that an R group is always going to start with a carbon and then become something?
Yeah, I mean, like we said, R is really a placeholder. So I'll give you an example. When R is H, what is the molecule? Huh? Water, which is obviously not organic. And so this leads to the idea that water is inorganic alcohol. So as long as it has a carbon group, then it's organic. If it doesn't have a carbon group, then it's not really organic. but it still might share similar chemical properties. For instance, when you look at the pKa tables, we talked about this last week. The hydronium ion, H3O+, has nearly identical pKa values to protonated alcohols. Protonated water, basically equivalent to a protonated alcohol. And when you scroll down to the alcohols, water's pKa is 15.6. Falls right in that range of alcohol pKas. So water is an inorganic alcohol. It does share some characteristic chemical reactivity, but it's not an organic functional group. So if you do want to make it organic, yeah, then it's got to have a carbon in there at some point. But a carboxylic acid does not contain an alcohol. Next, something similar to the ester is the ether. The bonding type here is ROR. Now, I am going to encourage you guys to do any fun, dumb, creative ways that you can recognize these bonding types. And I think ether is the one that I have the best dumb way to remember. The ether is an oxygen with carbon on ether side. Alcohol's got carbon and hydrogen on either side of the oxygen, but the ether has got carbon on ether side. So does the ester. The ester has carbon and carbon. That's what makes it an ester. So the way that I distinguish ether from ester, carbon on ether side, plus her sister ester. I don't know. That's just how I do it. I remember that ester's got two oxygens, almost like they're sisters, esters. Gotta find dumb ways to do this. Also, I remembered ketone. I feel like this was the one that clicked the least. I remembered ketone because it looked like a key a little bit. Not a lot. And then the way that I remembered carboxylic acid was that its shape kind of resembled that of the ketone, but it also looked like it had an alcohol in there. So I said that Dad kept the key to his alcohol in the carbox. Some of you got it, some of you didn't. And that's why you need to do it on your own. I can't give you my dumb ways of remembering it. You got to find your own clever ways to connect these, okay? After ether, something that's similar to an amide is the amine. The amine simply has carbon bonded to nitrogen. Can you guys think of what would be inorganic amine? Ammonia, NH3, is inorganic amine. And we know that ammonia is a weak base, and amines are actually pretty weak bases too. We don't deal a lot with amines in my class for OCHEM 1 or OCHEM 2 because they can be really challenging to control. That lone pair on the nitrogen loves to share itself a lot more than oxygen's does. And so it can be really challenging to control its chemistry. We'll have some nitrogen reagents this semester, but not a lot. So what's the distinction between amine and amide? The presence of the carbonyl. You'll notice on my functional group table that I actually highlight a few different types of amines. It depends on how many carbons that nitrogen is bonded to, what you might refer to it as. Bonded to one carbon group, we call that primary, attached to one carbon. Bonded to two carbon groups, we call that secondary, 2 carbons. Tertiary, it's bonded to 3 carbons. When it's quaternary, meaning it's attached to 4 carbons, nitrogen takes on a positive charge. So it's no longer an amine so much as it is an alkyl ammonium group. Ammonia, NH3, ammonium, NH4+, alkyl ammonium, like tetramethyl ammonium. Instead of NH4 plus, that is NCH3 plus. And a lot of medications that have nitrogens, those often get protonated. I think we talked about this last week with benzocaine. The nitrogen becomes protonated, becomes some sort of ammonium chloride salt, which makes it a lot more soluble in water. When it comes to the acid chlorides, the most common relative there would be the alkyl halide. But you'll notice that I'm switching from chloride specific to halide generic, and we'll just abbreviate this as RX, a carbon bonded to a halogen. And do you see something in that name that pulls you back to the hydrocarbon chains? It's that ALK group. So ALK, ALK, is telling me hydrocarbon-based. Alkyl halide, a hydrocarbon-based halogen group. And actually, we're gonna use this YL suffix quite a bit. You guys have already been hearing it and seeing it. Triethyl, tetramethyl, diisopropyl. That YL suffix is going to come back a lot to indicate that it's a part of, it's a substituent of. Okay, other than that, I really don't think we have a lot of comparisons to aldehydes and ketones. There are a couple of other groups in here that are interesting. The imine, similar to amine, but the nitrogen has a double bond to a carbon. So instead of amine, it's imine. Or the enamine and the enol. This is when you have a amine group or alcohol group bonded to the carbon of an alkene group. It becomes enol, enamine. Kind of hybridizes the two functional groups as one. And then we've got this specific type of ether that I do want to point out. We'll be looking at this group this semester. This is the epoxide. The epoxide is an ether because it has ROR, but it's a specific ether where those two R groups are bonded to each other. And then it can have other groups coming off of it. So an epoxide is this three-membered ring, this little triangle with oxygen. The last one, we won't see it a lot, but it will come up a couple of times. Those are the thiols and the sulfides. That's the equivalent of a alcohol and ether, but for sulfur. So thiol, RSH, sulfide, RSR. Now, yeah, Jamie.
Is methyl its own group, or is that just an alkene?
Great question. Methyl is not a functional group. Methyl would be an alkane functionality, but we'll use methyl a lot throughout the semester just as a way of sharing how many carbons are in the molecule, but this one carbon, this methyl, is not in line with the rest of the carbons. It sticks out from the rest of the carbon chain. That gets into nomenclature, and we're going to dive into nomenclature a lot more tomorrow. So more to come on what methyl is, but ultimately if you had a methyl group, you're really just saying you have alkane functionality at that region. Other questions you want to ask before I give you your task? Okay. we're going to do some moving around. And I'm going to put you into groups. I'm not letting you guys decide this time. I'm letting the universe decide. So what I'd like you guys to do is create a line. I think I'll probably have you guys create kind of this U shape, since I don't have a very clear wall anywhere. Create this U shape, organized from tallest, wrapping around to shortest. And then I'm going to pair you guys up. And I'm going to have you choose a functional group that you would like to analyze. And I'm going to have you find a functional group, find a molecule that contains your functional group and is related to your life somehow. I would like you to not choose the functional group or the molecule that you're doing your analysis on. I want the two of you to find a new molecule. And you're going to work together to find the functional group. So first you're going to get in a line, then I'm going to pair you, then I'm going to do an auction to raffle off these functional groups. So you don't get to just pick. It's going to go in reverse order of how you're paired. All right? So if you would stand up and create a U in order of tallest to shortest. Yeah, Sarah, I think you're.
We're all like
Same.
You guys want to blend into the middle a little bit? Give our short side some more space. Ella, I think you're going to go in front of Aaron. And Sarah, I think you're right in front of Jatsuri. It's a hard one. What do you guys think? Is Jamie supposed to be on the far end, on the left?
His shoes got less than me.
Okay, fair. Okay, so we're gonna have Kaiza and Jatsuri. You guys will be a group. So find a spot to work together and start thinking about what molecule or what functional group you'd like. Just keep in mind you're gonna be the last. Maybe I'll have you be the first to go. You're on the spot the most, and you get the most time with it. So you guys will have first pick. Fair?
Okay.
All right. Russ and Sarah, you guys will work together. Jamie and Aaron, Brett and Ella, other Brett and Hayden, Zubaida and Lisa, Maddie and Carly, Cameron and Abram, Cordelia and Rowan, and we'll have Hallie join you guys. You guys will be a group of 3. All right, find a place to work and start thinking about a functional group that you want to work with, and then I'll have you guys spend some time doing it. So why don't you guys do this? Take the next 2 minutes. 2 minutes to pick out your top functional groups.
Alright, this is from me.
You're just kind of
I
sure.
can't do that.
How are you, Ella?
I started new.
I feel the same. I'm not so I basically go to work, leave work.
I did work with
Yeah, for me,
that's a good question. That's so, that was really cool. I love that.
yeah, that's what I'm hoping. It's like
Okay.
yeah, so like the buildings that we're in, there's like ortho.
Sorry guys, there was a functional group I've left off of this chart and I keep meaning to get it on there. And I wanted to draw it to your attention. This is the nitrile group, sometimes called the cyano group. And it contains a CN triple bond. Some of you guys already drew that not cyano group in your molecule over the unit on the unit test over the weekend. So that triple bond CN, that is an important functional group that we're going to look at this semester and next semester. So that's the last thing. Okay. Now, I know you guys might not have had enough time to really narrow down which one you want to do, but I'm going to put you on the spot. That's the idea with the raffle. You guys are up first. Ketone. All right. I've got Kaisa and Jatsuri. Then I had Russ and Sarah.
You're gonna do ester.
Esther. And then I had Jamie and Aaron.
What do you mean?
Me. I think after that was Brett.
Yes.
Brett and Russ.
Alcohol.
You're gonna do alcohol. All right. Sorry, you know what? If I don't do this now, I'm gonna totally forget what order I put you guys in later. Then I had, was it Brett and Hayden next?
What's your carboxylic?
Carboxylic acids. It's so hard to remember. All right. Ether. And just make sure you don't find an epoxide. Then Maddie and Carlos.
We'll do aldehyde.
Aldehyde, awesome. Then I must have had Cameron and Abram.
Yeah. I'll do
The amide. All right. And then my triplets in the back. Nobody's chosen any of the hydrocarbon groups yet. I'm not trying to persuade, I'm just letting you know. Alkene? All right. Okay, so here's what I would like you to do. Find that molecule that has your functional group. Make sure that it connects to your life somehow. It relates to you. And then I'm going to have you bring those molecules to the board and draw them on the board. And in addition to the functional group you chose, we're going to work out any other functional groups that are in that structure as well. So you'll be bringing to the board the structure, its name, and its other functional groups. Deal? All right. Let's spend the next 5 minutes finding a molecule, and then I'll have you guys come up and share a little bit about them.
using our related to our lives.
I'm gonna use them. I'm not nervous. What do you think?
I think, yeah, so I'm not in the alcohol, and then you see the other functional groups. Methylamine is used in pharmaceuticals. So that relates to registry and medical stuff.
Yeah.
Yeah. Ethylamine is a herbicide. No.
Definitely, because I wanna go into microbiology. So specific.
There's also.
We all love that.
I worked in the student. This one's a student. Yeah, so can be the different.
Oh.
Might have had
I just remember I tried to work with my bench.
Other functional groups.
What field are you?
I'm going into medical laboratory technology for microbiology, but also
Because they have the.
which one?
I think it's a few.
I mean, well, if we look at the marine, what would you say would be another functional group? Could that be called? Because it's not really an
No,
R.
that would be more of an alcohols.
All right, I'm guessing by
It's
the
gonna be alcoholic.
reduction in noise
Oh, okay.
that you guys are feeling pretty good about what you've got. So why don't we take a quick break? If you need to, get up, move around, get your blood flowing again. And then by the end of our break, I'd love for you guys to have your molecules brought up and put on the board.
Let's just do like, a medicine.
Yeah.
There's a pseudoephedrine. Oh wait, no. We have an alcohol as well. Just a minute, like distance.
Oh, yeah.
We decided this one wasn't mine.
I mean, when, yeah, it's the same with alcohol.
It has secondary amine structure. It has alcohol coming up. Really good.
There we go, methamphetamine.
Have you seen Breaking Bad?
Yeah.
I was thinking methylamine.
It can make meth. You can do a lot of stuff with methylamine.
Yeah.
Well, methamphetamine is pseudoephedrine.
It wouldn't be the first time I had a group put methamphetamine up here for this activity.
Really?
It wouldn't be the first time I had a group put methamphetamine up here for this activity.
That's funny.
And the last time the group related it to their lives, they said, I work, I actually don't remember. She's trying to become a dentist, so I don't know.
It took me a second.
But I think,
Well, actually, no, that makes sense. I restore people's mouths and it causes teeth issues.
good point, yeah.
Yeah.
I'm a drug addict.
We take all kinds here.
That is interesting to see it next to each other, and the difference is like that broken off alcohol group between the pseudoephedrine and the methamphetamine.
Yeah,
Like, that's it?
yeah. The similarity between some of these molecules is crazy. Actually, the methamphetamine has what we call a chiral center. So it takes up space in the same way that your right hand does relative to your left hand. Exactly the same, but exactly opposite. And the enantiomer, the relationship between your two hands, the enantiomer of methamphetamine is the active ingredient in Vicks Vapor Rub.
Okay.
Is this an?
Yes.
Yeah.
Not a
Alcohol is this, not an amine, because it's part of that in my.
Oh wait.
Correct.
Sorry.
Same with that one.
Correct.
And then
But this is you could call it an amine or an enamine.
aromatic ring.
And this one is actually an imine. It's IME.
Technical way of airing.
So that one
Alcohol,
because it's carbon.
amines,
That's right.
and then alcohol.
The alcohol is the same. Is-
I'm gonna.
Okay.
Good. What
What was that acid that you were talking about last week? That's scary.
Hydrofluoric acid.
Yes, so my husband worked with that. He worked at it shut down, Fairchild, semiconductors,
Oh.
and they worked with it, and they actually they had a calcium paste that if you suspected you might have gotten it on you, you put that paste all over where you thought,
Oh,
so it would suck it to that instead of going into your bone.
I didn't realize that you could get it out.
Yeah, that's what he said that they did. Like, he didn't have any actual chemistry training.
Every lab I've seen that uses it, big danger signs on top.
So, right,
You'd be better off just
yeah. We don't.
You know, if you like that slide.
Like, it's understandable. But the reactivity of the pi bonds in the aromatic ring does not resemble the reactivity of a carbon-carbon double bond.
Yeah, it's.
And that separates them out of Right. So I like that similar to how the carboxylic acid does not have an alcohol, the aromatic ring does not have an alkene. If you guys are ready, go ahead and draw your molecule. Put its name up there too, and then look at the other functional groups. Are you guys ready? Yeah, feel free. If there are any other functional groups in your molecule, then look them up. This is the one you guys have. What was the connection? How does it connect to your lives? Yeah. I like it. And you're in the lab, we use it a lot in the lab, so you'll get really familiar with it. Great, yeah. So you guys, yeah, John's structured his name, but you actually don't have any other functional groups. That's okay.
So it looks like it's just ion.
You guys ready? I don't think there is too simple. It's, I think it's good to actually have a lot of different stuff. Diversify it. Have small molecules and big molecules. Russ, you stick around to Oakham 2, you'll get to make that. Yeah? Mm-hmm.
Do you want us to label?
Yeah, you want us to label
Or just put it up there and describe it?
I guess, I mean, this is okay, and we can talk together about what other functional groups are up there.
Are we drawing, or also writing what functional groups are?
If you want to, otherwise we'll do it. I'll do it together anyways.
Okay.
So, I remember we talked about quality. You said you
Hmm.
said
I don't remember saying that. Oh, yeah, that's true. No, he's in grad school, and he's graduating soon with his PhD.
Oh, that's so cool.
But he's applying to fellowships.
Okay, I think that's.
Yeah.
So you're gonna have to move.
Yeah. I would love to stay here until the day I die. And with the arsenic that the Great Salt Lake is pumping out, that's probably sooner than later. So if his fellowship doesn't take us both out of the state, the Great Salt Lake would eventually. I mean that. It's like it's a scary place to live when you know the chemistry that's coming out of that place.
Because aren't they trying to drain it? Is that like?
The opposite. Like everybody is doing their best to fill it. Not everybody's doing their best. A lot of companies are like finding loopholes so that they can keep using the water. But because of decreased rainfall and snowfall and increased temperatures, the lake is just evaporating at unprecedented rates. But also the lake has been evaporating for like millennia, you know? It used to be an inland ocean. And then the dam broke and it became that smaller lake, and the lake has been evaporating for a long time. That's what you expect from a dead lake. It's just not somewhere you want to set up a thriving civilization, is next to a lake that collects all of the toxic. You know why there's a lot of toxic metals too? It's not all natural. There's a lot of mining that happens in the Salt Lake Valley. And all of that mining takes out toxic metals from the mountains, and then they just wash that downstream into the Great Salt Lake. So I would say there's a lot of conservation groups that are doing their best to keep it full. And then there's a lot of corporations that are doing their best to save money in their bottom line. And that means cheap water.
It's really bad.
Do you guys know that golf courses in Utah don't really have to pay a water fee? And they use a lot of water. And I think the loophole is that the golf courses are primarily run by the counties.
Yeah.
Which I hate. I was looking for an apartment a few years ago, and there was one spot right next to the golf course near here. Looked right at the golf course. I was like, if I rent this apartment, I will burn down that golf course. I do believe that golf courses are a source of evil in the world, and I say that as someone whose mom created the women's golf club at her high school and went to state. I just think that golf courses should exist where golf courses are naturally a habitat. And a desert climate is not a natural habitat for a golf course. So if you want to golf, go fly to Wisconsin. You've got plenty of pasture land you can golf in. Stop building more golf courses in the desert, sucking up the only water we have. I digress. Let's talk about chemistry. All right. So Kaisa and Jatsuri gave us acetoacetate. Talk to me about how this applied to you.
Well, the first thing I thought of reading that was like the keto diet.
Yeah.
That's very popular. So I was curious if the molecule or the chemicals our liver makes from it like actually have the functional groups in it, and this one did. And the primary thing it does is it just gives it's another source of fuel for the body when
Nice.
you're like fasting or in that ketosis.
So the keto diet, a way of going into ketosis to burn more fat, right? And this molecule is metabolized in the liver or created in the liver so that it can be used for energy. Great. So we've got the ketone functional group, R-carbonyl. There's our ketone. What other functionality is there in this molecule? It's a little bit hard to see it because it's actually the conjugate base of one of our functional groups. What we have is a carboxylate. When I've got this CO double bond OH, and then that gets deprotonated. So if this were protonated instead as an OH, this would be a carboxylic acid. but because it's not protonated, it's a carboxylate. So I'm going to say carboxylic acid in parentheses, but carboxylate otherwise. Cool. All right. Also, I wanted to talk about the name and how sometimes the name does or does not imply the functional group. When you hear acetate, it's actually meant to imply the carboxylate group. But aceto, and you actually see aceta in here twice, acetoacetate, acetate. This ACET group is a common name. It's not systematic, but it's commonly used to refer to a CH3 group that has a carbonyl. And so you see the CH3 group with a carbonyl, and then also this would have been a CH3 group with a carbonyl, except that it's been substituted with another acetyl group. So this is acetate, this is acetoacetate. It's meant to imply that there are kind of two of those one carbon-carbonyl groups. I don't like that common name, but it's prevalent and you'll see it a lot. Let's go to Russ and Sarah. You guys chose isoamyl acetate, aka banana oil. It's not necessarily found in bananas, I'm not sure. But it's found in Runts, that candy, or a Laffy Taffy banana flavor. And it smells just like the candy. If you guys stick around to OCHEM 2, we synthesized this molecule in OCHEM 2. And it smells great. How did it relate? We all like candy. Love it. The ester functional group is right here. Actually, maybe I need to expand this a little bit more, right? Because it's not just the carbonyl bonded to O, it's the carbonyl bonded to OR. So after we get this point, we know it's an ester group. It doesn't really even matter what's over on this side. Does it have any other functionality? Any other functional groups?
Yeah, we just said alkane and the ester.
Yeah. Generally, if you've got one functional group like ester and then no other unique bonding, a lot of people won't even say that this has alkane functionality. It's like, yeah, sure, it does. It's just not prioritized as much. But I would agree with you. The rest would be alkane. Jamie and Aaron. Pseudoephedrine.
Yeah, it's a nasal decongestant, and she's going to the medical laboratory science. I'm going to dentistry and just pick something medical.
Good.
And it has 2 alkanes and an alcohol and a secondary amine.
Good. So here's the amine group, the fact that it is carbon to nitrogen to carbon. And it's secondary because that nitrogen is bonded to 2 carbons. And I agree, yeah, it's got alkane functionality. It's got this alcohol, ROH. But there is one other primary functional group. It's got this aromatic ring in it.
And the pseudo comes from, so ephedrine has a wedge into the hydroxyl
Okay.
and a dashed line above the amine.
Yeah.
And the pseudo just has a dashed line instead of a wedge into the hydroxyl.
So what you're describing there is stereoisomers, things that are bonded exactly the same, but their arrangement in space differs. So stereo there is referring to their spatial arrangement. So that's interesting. It's pseudo, I think we know, is a word for fake or similar to, but fake. And so ephedrine must be the molecule that was first discovered, and then pseudoephedrine was named as if it wasn't really ephedrine, but it was like it, but fake. Because it's not going to have all of the same properties by being a stereoisomer. Okay. What's interesting about pseudoephedrine is that you couldn't pick out any of the functional groups based on that name. No part of the name pseudoephedrine tells you that there's an aromatic ring, or an alcohol, or an amine. So that's a common name that, in my opinion, does a bad job at delivering what the molecule is. Isoamyl acetate is actually fairly similar. Remember I was telling you about this ACET group, acetoacetate, and here we've got acetate. It's that one carbon carbonyl group giving us acetate. But what is isoamyl? It's a common name. It's not something that I will expect you to know because it doesn't deliver a systematic way to approach it. Okay, we're moving down here. We've got Brett and Ella.
Yeah, so we had the alcohol and we chose ethanol. We chose ethanol just because
You're in college.
Yeah. But it's used a lot in by endodontists for root canals. It's like the final like irrigation system.
Yeah.
For it. Just
Sanitizer.
Yeah.
All that alcohol kills any bacteria that could be in there. Any other functional group in ethanol?
We found what would we call it? Alkane.
Yeah.
Yeah.
So here's what makes it an alcohol. It's that COH. And then the only other part would be alkane. Good. Now, in terms of nomenclature or naming, ethanol does a pretty good job of describing what the molecule is. So what we see in ethanol is eth, which is a root that we're going to learn describes two carbons. We see ane, which says that the only hydrocarbon functional group is alkane. There's no alkene, there's no alkyne. This AN actually tells us that. And then we've got all, which sounds like alcohol. And so the name does a really good job of telling us every carbon that's in the structure, how it's bonded, and what other heteroatoms are there. So this is a systematic name. Russ, you had a question?
Yeah, sorry, this might be too much of a sidebar, but I was just curious, what about alcohol allows it to kill bacteria? Is it the H's becoming like an acid? Or
No, because like we said, alcohol is organic water, you know? So I think that it has something to do with, I'm going out of my depth here, hypotonic, hypertonic, osmosis. So I think the attraction between water and ethanol might help pull water out of cells, and that can help break down bacteria. I could be wrong about that.
it's good enough for me?
It could also have something to do with, ethanol is a toxin. Almost all alcohols are toxins. So you drink too much ethanol, your body tries to break it down and you're basically poisoning yourself. So it could be something similar that these single cell organisms take in ethanol and they break it down and they just kill themselves with the toxin. I think that's a bit out of my depth, but a couple of theories that could be there. If anybody else knows, feel free to share. Okay, let's move on to Brett and Hayden. You guys chose creatine. How does it relate to you?
How does it relate to us personally?
Why did you choose creatine?
Pretty much every human uses creatine. It's just produced endogenously.
Endogenously. That's a nice word. Meaning we create this ourselves. Yeah. Nice.
So basically in your muscles, creatine will be stored as creatine phosphate, and the phosphate is donated to ADP. So the resynthesized ATP.
Okay.
So if you take it orally as a supplement, you're taking more than you would otherwise ingest from your diet, then you're hypersaturating your muscles with that.
Sure.
It can help with strength.
Helps you create more energy when you eat it.
Yeah.
And it's an amino acid. We see the amine group and we see the carboxylic acid group. And that's what you guys had chosen this for. You chose it for the carboxylic acid. But we see that because it's an amino acid, it also has an amine. And then it's got a couple of other interesting things. Like here, we have an amine attached to a carbon that's in a carbon-carbon double bond, a carbon that's in a double bond, but not a carbon-carbon double bond. So this would also be just an amine, but this nitrogen up here is a nitrogen double bonded to a carbon, which makes it an imine. And you'll learn about imine reactions and characteristics in OCHEM 2. We won't study reactions that make it in OCHEM 1. Interesting stuff. Is creatine an amino acid?
Yeah.
Interesting.
It's a non-essential amino acid because you can produce it endogenously.
It's wild. It's wild that you could take something else and turn it into that. I don't know how you do it. It's not my field to answer either. Let's talk about the name, creatine. Does it tell you what's going on? Does it? Okay, yeah, I could see how I and E kind of applies to the I and E there.
Yeah, that's just the physiology jargon. So dopamine, serotonin, epinephrine.
Okay,
Those are all amino hormones.
I hear it the most in dopamine because it's actually
It's
got
the way we
amine.
say it. My professor brought up that in England they call epinephrine.
Well, in England they call it adrenaline.
It's called adrenaline
That's
everywhere.
synonymous.
Yeah, it's
True.
totally synonymous.
True.
We just changed the jargon because we originally discovered epinephrine. We named it adrenaline because we sourced it back to the adrenal medulla,
Mm-hmm.
and then we realized it's used as a neurotransmitter as well. And then we use and then there's norepinephrine.
Is it outdated though that the
It's
medical terminology in the U.S. is epinephrine, but the medical terminology in the U.K. is adrenaline?
It depends on the manufacturer.
I
of the
think they
medication,
call it-
too. I've seen
yeah.
vials of adrenaline and epinephrine. It's
they're
exactly.
totally synonymous.
Interesting. That is an interesting idea that the I and E ties back. I wouldn't have guessed it, but I agree. The pronunciation changes, like amine, creatine. You don't. It's not always pronounced as creatine, so you don't always hear that "ine." But I've got a similar idea for that. I'll get to you, Hallie. I've got a similar idea, a story to that, which is the halogen family. You've got fluorine, chlorine, bromine, and iodine. It's not pronounced iodine, even though it's spelt exactly the same. And I think something happens when a word enters the common vernacular. It changes pronunciation to be as easily pronounced as possible. And so that's an interesting relationship. I like that. Anything else you guys want to say on your molecule? Good work. You got a question?
Yeah, sorry, could you go over one more time how it changes from the amine to cysteine?
Yeah.
I didn't really catch that.
It's not always.
Carbon, nitrogen, single bond, amine. Carbon, nitrogen, double bond, imine. So it's all about how many bonds it has to the same carbon.
Okay.
And then we saw earlier the carbon-nitrogen triple bond, nitride. All right. We've got Zubaida and Lisa. You guys chose diethyl ether. Why don't you share with the class why you chose that?
Well, I went to Boston a couple weeks ago, and we had a tour of the Mass General Hospital where they have the ether dome, and they just gave us a history of the uses of ether, and I just kind of connected, and I thought it would be interesting to get deep down to the chemical things of that anesthetic, that it was used previously as an anesthetic.
So diethyl ether is still a very common organic solvent in organic laboratories, but it used to be used as a medical anesthetic. We know now that it has some pretty negative health effects when you ingest too much of it, but when you were living in the 1800s and it's either die now from your wounds or die later from poisoning from diethyl ether, I think you'd rather take this. The ether functionality, it's got this ROR. So we could maybe say that it's also got alkane functionality, kind of like the rest of these, but really ether is the main functional group there. All right, now we've got, I just have to find you, Maddie and Carly with your aldehyde. You guys chose acetaldehyde. I want to draw your attention to the ACT, acid. We've got acid, acid, acid. Any other ones? Nope, just that. So kind of drawing you back to that common piece in nomenclature representing the one carbon and the carbonyl. So why did you choose acetaldehyde?
So it's basically like a liquid gas, and it's commonly found in like various like foods, like fruit and coffee. So I like fruit, and she likes coffee.
Now, a liquid gas. How does that work? I mean, gasoline is a liquid that we call gas, but what do you mean? That it's a liquid at room temperature, but it easily vaporizes?
I don't know. It talked like what I read about it is that it was like an ethanol metabolizer. I don't know if that relates to like.
Well, I don't think I'd call it a metabolizer. I think the word is metabolite. It is formed by metabolizing
Yes.
ethanol. You can see ethanol has the 2 carbons, and one of them has the CO group. If you remove one H from that carbon and the O from that carbon, and then create a double bond, we refer to that as oxidation. You've oxidized that carbon, and that makes it acetaldehyde.
Why is that said acetaldehyde instead of acetaldehyde?
I don't know. In fact, in the spring, I had a group that chose this molecule as well, and I called it in front of the class acetaldehyde, because to me that sounds the most accurate and it rolls off the tongue better. And they like everybody stopped me and they're like, "No, I know biology. It's not acetaldehyde." Good. Go teach yourself then. No, I don't know. I don't know. I think it's what happens, you know? Like somebody said, I think this sounds better, and then it caught on and it stuck. And again, we could maybe say that it's got alkane functionality, but really this is just an aldehyde. And the name tells you that there's that aldehyde, but you've also got to understand what acetyl is trying to tell you. It's telling you that there's just one other carbon besides the carbonyl carbon. All right. Now we've got Cameron and Avery.
Yes, we did lidocaine because we use it all the time in our jobs, just
Numbing things. A local anesthetic.
Yeah.
And you went for amide.
Amide, which we kind of pointed to right there, and there's a couple other things.
Yeah. So we also see the amine, specifically a tertiary amine. It's connected to 3 other carbons. And we've got this aromatic ring. And we could say that this is a tri-substituted aromatic ring. It's got these 2 CH3 groups coming off of it, and it's connected to the amide. Lidocaine, does it help you predict anything about the structure? Does the name inform about the molecule? Not at all.
Maybe the INE.
Yeah, actually that's a good point. It's got an amine, and we see the INE. We just learned about that from creatine. The name lidocaine, though, it does sound like something. Sounds like a derivative of cocaine. And that is because lidocaine, benzocaine, there's some other canes in there. What? Novocaine. They were all synthesized as a substitute for cocaine. Cocaine was known for its anesthetic properties. It's a great anesthetic. It just also makes patients incredibly addicted to it afterwards. So people wanted to find a way to get the same anesthetic effects of cocaine without the addictive properties of cocaine. And that's how we got benzocaine, lidocaine, and novocaine. So they are a part of the cocaine family. All right, we've got Rowan, Cordelia, and Hallie. You guys chose caffeine. And you chose it for the alkene, but what other functional groups did you find? Couple of amides. So we've got this carbonyl here that's bonded to a nitrogen on both sides. So that's kind of a double amide. And then we've got this other carbonyl that's bonded to a nitrogen on one side, and so that's also an amide. Are any of those nitrogens amines? No, because those nitrogens are already amides. But then we've got a couple of other nitrogens, And it's good that we reviewed this, right? A nitrogen with a double bond to carbon, that gives us the imine. And then we've got this nitrogen single bonded to carbons, and so that's our amine. But this nitrogen is also bonded to the alkene, which makes it maybe also an enamine. It's an alkeneamine. We circled just about every single atom in that structure. There's a lot of things going on in there. And I know a lot of you actually submitted for your analysis project caffeine and lidocaine and some other common biological molecules. And we couldn't do them because there's not a lot of chemistry that we're going to learn how to do, changes in functional groups that we're going to learn how to do with those molecules. So keep reviewing your functional groups. Get them down, because a big part of this unit is just being able to recognize that functional group based on those bonding patterns. And throughout the semester, we're going to come back. We're going to change them. We're going to synthesize them. It's going to be a good time. Thank you guys for your time. I'm sorry for taking you over. Have a good day, and I'll see you tomorrow.